Hi there, and thanks for checking in. Let's continue on with our study of how to find the slope of a line. We've been talking about slope for a few days now, and let's just do a quick recap of what we've already learned about slope. First of all, we know that slope is represented by the letter M. That's important to remember as we work our way through this unit. You're going to start seeing more and more of the M and less of the word slope. So you're just going to be expected to know what M is. M represents slope. All right, now what is slope? Well, in my own words, slope is the steepness of a line, right? How steep is the line? And what kind of lines? What are we talking about? Well, we're talking about lines that come from linear equations, lines that have been graphed on a coordinate plane. So we've talked about slope being equal to rise over run. And if you recall, rise, like if you're looking at a set of stairs, rise goes up, and then run goes side to side. And then rise goes up, and then run goes side to side. So the distance of the rise, let's say it's 3, that would be your numerator. And the distance of the run, let's say it's 4, that would be your denominator. So if this is the line that I'm calculating the slope of, rise and run is always 3 and 4 and 3 and 4, the slope of this line would be 3/4, right? Up 3 over 4, up 3 over 4, up 3 over 4, so on and so forth. So we've talked about slope being rise over run. Then we talked about calculating slope if all you're given are 2 points. So we talked about M being equal to y2 minus y1. That's your numerator. And x2 minus x1, that's your denominator. Where again, these y2, y1 values, x2, x1 values are coming from 2 points on the line. Or 2 sets of ordered pairs. And that was all, plug the numbers in and then do the subtraction on your calculator or do the subtraction in your head, and then you arrive at the slope that way. That was a previous lesson. So now today, we're going to look at how to calculate slope for a line if all you're given is a table of values. And I'm going to kind of put this in different terms today. I'm going to call it change in the y goes on top, and the change in the x goes on bottom. So change in y over change in x. Okay? And hey, just a little side note here. Maybe you don't really care. But in science, change is represented by a triangle. So you know what? In the future, if you ever see this, change in y over change in x. You don't really have to know that for today's lesson, but it is kind of an interesting little fact that change in y over change in x can be represented with little triangles. Okay, so we're going to be finding the slope today of a line if all we're given is a table of values. Now, you should know about table of values. For goodness sakes, we worked with them for about a week. A table of values can look like this. Remember this, where you'll have like a 2 and a 0 and a -2, and then you'll have some values there for y as well. You're used to seeing a table of values like that. And then this would become like, your ordered pairs, right? Well, don't be surprised today if you see a table of values that's been tipped over so that it looks something like this. And these become your ordered pairs. So sometimes a table of value is vertical, and sometimes a table of values has been tipped over so that it's laying on its side, or it's horizontal. In fact, that's the kind of table of values that we're going to be looking at today. We're going to be looking at this guy. So let's take a look-see. If slope is equal to the change in the y values over the change in the x values, specifically talking about looking at a table. So here we go. It says the points in the table lie on a line. All right, so if you were to plot these, x's and y's, they would actually make a straight line. How can you find the slope of the line from this table? What is the slope of the line? We give you a hint. Choose any 2 points from the table and then use your slope formula. All right. Now, I'm sure some of you are thinking, 2 points? I don't even see anything that looks like an ordered pair. Well, that's because they've taken this table of values and laid it down horizontally. These are ordered pairs. This is the ordered pair. This guy right here. This is the ordered pair 1, 8, right? The x value is 1, the y value is 8. This is the ordered pair 4, 6. This is the ordered pair 7, 4. And this is the ordered pair 10, 2. So it's just that they've taken their data and rearranged it into a bit of a different format. A little different than what you're used to seeing, but certainly still something that we can work with. Okay, so remember, its slope is equal to the change in y over the change in x. Okay, so let's go back to our table of values and let's look at our y's. Let's look at our y values. I'm going to erase this for now. You can pick any 2 that you want. Oftentimes, I just pick the first 2. So I'm going to be comparing these 2 y values, okay? What is the change in those 2 y values? And again, I say you could pick any 2 y values that you'd like. I'm going to use the 8 and 6. You could use the 6 and 4. You could use the 4 and 2. You could compare the 6 to the 2, but you have to be consistent. If I'm going to compare the 8 and the 6 for the y's, then I also have to compare the 1 and the 4 when I do the x's here in a minute, right? You have to be consistent. So, starting with an 8 and going to a 6, how do you get from an 8 to a 6 mathematically? It's minus 2, right? So that becomes your top number. So the change in y down here was a minus 2, or negative 2, or down 2. Now, for the x's, you have to compare the same 2 x's that you used for the y. So in other words, I have to use the 1 and the 4 now. Because I used the 8 and the 6 for the y's, I have to use the 1 and the 4 for the x. So, starting with the 1, going to a 4. How do you get from a 1 to a 4 mathematically? Or if you were counting these spaces on a graph, that'd be a positive 3, up 3. So your denominator now is a 3. So you've done it. That's it. You've calculated the slope of this line just by looking at a table of values. And the slope of this line is negative 2/3. And I'm hoping by now that you know that a slope of negative 2/3 means a line that's going down to the right, and specifically, it is going down to right 3. Down 2, right 3, 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 down 2, right 3. Get the idea? And you know, the cool thing is, well, I mean, I guess it's kind of cool, is that this slope of negative 2/3 is consistent through the entire table. So if I were to look at 2 other points, let's do 4, 2. How do you get from a 4 to a 2? Negative 2, right? Down 2. So there's that negative 2 again. Now compare the 7 and 10. How do you get from a 7 to a 10? Up 3, positive 3. There's your denominator of a positive 3 again. So it doesn't matter which 2 points you compare because the table is consistent with its slope. The slope is the same all the way through the table. All right? So you have to remember that a table of values can sometimes be horizontal, and it's really just ordered pairs that are arranged a little bit differently than the way we're used to seeing them. But it's still change in y goes on top and the change in x goes on bottom. So in class then we're going to continue to work with our practicing calculating slope. And this is just a real brief review here of positive slope, negative slope, a line that has a slope of 0, and an undefined slope. So here's your positive, here's your negative, Here's a slope of 0, and here is that undefined slope. Vertical line, undefined, so much slope you can't even measure it. Just a quick review there. Okay? I will see you in class.